There we go.
I think the question, wasn't there a question surrounding, do we need a constructor or not?
That was it, right? And I think someone said that we don't because we can just draw the first couple cards, right? Like we did, like some, I guess, like, yeah. I was wondering. What I'm actually really happy is that no one came in and said, "Oh yeah, we need to do that because we need 2 cards right away." You actually don't need 2 cards immediately. When you sit in front of the table, you do have a hand to store cards, but you don't start with those cards. You first have to bet first. So the constructor definitely doesn't need to have cards in it. We can just add cards to the hand and then just run that twice. And so for the moment, we don't need a constructor. We can use the default constructor, but what we are going to need is some way to put cards in our hand, right?
Yeah, you show your recording, right? Because I never got.
I hit it. Yeah, I heard it.
Because you already consented.
I already consented earlier. That's
If you, I will say, if you click on participants and look at my name, you should see a little red dot next to me.
And also like on the top left, it should be a recording.
Oh, cool. I didn't see that. I don't know if that shows up on you
Oh,
guys.
yeah.
I'm usually the one recording, so.
This is, next to the shield, it says recording.
Ah, cool. Oh yeah, I see that on my own share screen. So yeah, but yeah, there's multiple ways to see that I'm recording. So, yeah,
right.
We're good. All right, so we don't need to add those items, but we do. If you notice here in our hand system, we have display hand, get value, hit, stand, double split. We can definitely do the display hand method, but what are we going to display right now? If I do that. If I was to run the display hand method, what am I going to display? So again, look through the code. This is this idea of like hypothesizing what's going to happen without even needing to write code yet. This is how you help. This is why I do this, is to help help you guys understand my thought process. So it's like, I see my plan of attack. My next thing is to do is to display the hand. So if I write display hand, so I'm going to do public. We'll do strings. Well, for the moment, or void for the moment, because maybe I'll just do a system out for the moment. We'll do display. So with display hand, I'm going to, what am I actually displaying? What am I going to display?
I would say.
Odds array?
For the cards list, right?
Yeah, list.
And if I was to run this right now at this moment, what am I gonna, what's actually gonna be output?
Well, nothing because you don't have any cards in it.
Yeah, there's no cards in it. Okay, cool. So wait, how do I put cards in here? I need some way to add cards, don't I? And that's why it helps to analyze what I have existing when I go to make a method. Oh yeah, I can display hand, but and I'm going to display this, but there's nothing in it. Well, it's a private item, so I can't just access it directly. So if this was public, I could argue, oh, well, I'm adding cards in a outside class, right? That I could logically deduce that maybe cards.add was run somewhere else, right? That it was run from outside of this class. I could assume that. And here, because cards is private, there's no way for an external class to add cards to it. But I also have no code here in the hand class adding anything to it right now. So with those statements, I can logically deduce that there's no way for cards to have anything. So the display hand is right now redundant until I make some way for us to add cards. So there's right there is a method that we didn't think of in our plan of attack, which is perfectly fine. Because we had this display hand method, it helped us to realize we need a way to add cards to our hand. So public void, add card. All right, and so to add a card, what do I need? What do we need to do here?
Well, you need to get the card.
I do need to get a card. So I don't want to create a card. And where, if we had to use our logic again, where would the card be coming from if we had to assume?
The deck.
True, the deck. And then are we going to pass the deck and draw here, or should we maybe, is it safe to assume that the draw method is going to be run by someone else? They're just going to give us the one card. Does the hand need to grab the deck?
Someone's going to give the card.
No.
Yeah, we don't need to grab the deck, right?
So
I'm pretty sure if you reached across the table at the casino and grabbed the deck to take a card from it, they're going to stab you. Like
Keith,
fork
is
in the
that
hand.
No.
I'm pretty sure they won't let you grab the deck though, right?
Yeah.
True.
So card. And all I'm gonna do is do cards dot add card. Very simple, right? Think that follows the SRP? Single responsibility principle?
That definitely does.
Yeah, and this is again another way we could also argue that we don't need the deck. For example, if I was to take this and just for the moment, we're going to make an overload just for the fun of it. I'm going to pass in a deck. I'm going to do deck.draw. Is this doing one thing now? Is this just adding a card? Is this doing something else now? Is this doing two things technically? Could you argue?
It's still doing one thing because you're taking in you're still drawing one card.
Kind of, we're drawing and then adding it. So you could argue that this is more excessive. Instead, and you could and the idea is that we could look at this and be like, oh, I can simplify this by just accepting the card instead of accepting the deck, then drawing. I can let someone else handle the drawing. And this way I can also, I don't have to only accept the card through a deck. In other games, I can also get a card by just asking for a card, or by if I did include Old Maid, what was it? Old Maid. If I included Old Maid still, you would actually just pull a card from another player's hand and add it to your hand, right? So this is where like simplicity matters. Deck.draw is going to give me a card, so maybe I should just have a card version. And in this case, what should happen then, in how a lot of things will do this, and actually what you see a lot, and if you do check some of the built-in methods of Java, is that you probably would have an overload like this, but how this overload would actually be written is instead of using cards.add twice, it's going to do add card deck.draw. And this would be the overload. Why are you yelling at me? What did I do wrong? Oh, C. There we go. And so this is commonly what you'll see as an overload in the Java's actual written syntax, is that if they have a less specific version, the less specific version will just call the more specific version and send the item needed. So that's usually what you'll see. We don't need this, so we're going to get rid of it, but just want to make sure you're aware of that. That way, again, this item is technically still doing one thing. It's first pulling the card and then letting another method actually add it. So this is doing one thing, it's drawing the card, and this one is actually adding the card. So it still kind of follows, this now follows that single responsibility principle. This one's in charge of pulling a card. This one's still in charge of adding the card. Cool. Now that we can add cards, let's go ahead and display the hand. How do I want to display the hand? So it should be an easy one. How do I display the hand?
We have a display method, don't we?
The cards have a display method, right?
Yes, that they do.
Good. So I want to use the display method on the cards, but I want to make sure I print every single card. So how do I do that?
Gotta iterate through the deck.
All right. What iterator am I using?
No, yeah, iterate through the hand or the cards.
And which iterator am I using?
4N.
Thank you, people. Come on, people. It'll be second nature now. For card in cards. Card dot display. Right?
I was going to
Now-
say,
Gonna say while
that?
true.
I wouldn't do that. So if you take a look,
No, I know.
and again,
I know.
this is very useful for IntelliJ. We know that our display method is going to return a string. It's actually not going to print it. So this is not actually going to print. So we have two options. We either want to return the string again, or we want to actually S out it. So for the moment, we can start by S outing it just to see what this is going to do. What is this going to print, right? We're going to decide, do we still want to print it this way? Do we want to return it as a string? What do we want to do after we print it once? So let's go ahead and do S out. All right, so we have that. And looking at this, do I have enough to actually run something on a test now? Could I actually build a hand now? What do you guys think? Is this testable?
Is it?
Yes.
I think so, yes.
Let's try. Go back to main. So we are able to draw cards. So we're going to keep these here. We're going to get rid of this. Let's go ahead and do a hand. So hand hand. I forgot to import. We'll do that in a second. Equals new hand. There we go. And then we have no constructor, so just that. We're gonna go ahead and do my hand dot add card deck dot draw. I'm also going to change the item back to being a standard deck because I don't want to have to type it in. So standard deck. How many cards does Blackjack have in their hand when you first start?
400.
How many?
52.
No, how many? How many cards in your hand? Pain.
Two.
7.
Two.
Oh,
So do
lot of
that.
cards. Oh, lot of cards.
Oh wait, I forgot to hit the display method. So it ran, but
Hey, look, it worked.
Yeah. No errors.
that display hand. Let's try that again. All right, we got king and 9. Right, not bad. Run it again. Make sure we get different cards. 8 and king. The diamond instead this time. 5 and 4. That looks fine. But I probably want to change this a little bit, don't I? Do we want them on new lines or we want them on one line? What do you think?
I think one line would be nicer.
And we're,
Yeah.
I feel like we have a lot of like empty retail space over here, right? So let's go ahead and update that. Let's go back to hand. And so now if we want to make sure we print each one of these on its own line, how do I change this?
Take out the LN.
What's that?
Take out the LN.
Could do that. That's going to do something a little different.
You gotta still put a space though. Oh no, the space is
Well,
automatic.
we currently have one because the 6 has one right now.
Yeah,
The 10 doesn't.
yeah.
So we do need to put a space in there. As we could, of course, just do this. That is fine. But for me, that makes me a little annoyed on one hand as a efficiency system because we have this blank here now, extra space at the end, and I don't like those. So usually a lot of times what you want to see is some sort of string builder. And I want you guys getting used to doing that concept of doing a single system out instead of multiple, because that actually does also take up more resources of printing multiple times versus building out a string and printing it once. So do be aware of that. So, and I'm going to convert this once we do it once, but let's do let, oh, not let, just JavaScript. String output, empty quote. Go ahead and do output plus equal that plus the empty space. And I'm going to do return output dot trim. Why does trim? What does trim do for me?
Thoughtful things at the end.
Yeah, it gets rid of that extra space at the end. And we'll just
Semicolon
update
on
this.
line 19.
Thank you. Also going to do that. Update our method to return a string and do that one. Anyhow,
Yeah.
we're going to convert this to see what it looks like. Because I haven't really done much with string builder because I usually don't want to introduce it usually, but I think we're going to introduce it now. So let's convert it. We use dot append now.
And you just keep dotting appending everything that you want to keep adding to. So you do dot append, dot append, dot append.
Interesting. All right. It's not that difficult. And now I'll let you guys make, I will say string builder is something that is good to know. They are going to recommend it eventually. What is it recommending here now? Okay, that's fine. We haven't used it yet. Okay. All right. So we have the appends. We head back to main now. We just got to go ahead and encompass this in an S out now. So we ended up returning string, which I could have, I guess, just done the S out in the method, but it's fine. And this time we'll see what we want. 7-5 to ace, GG. Also, trim also removes the ones in the front. So if your first letter actually doesn't have it, you won't also get a preceding space anymore either. So that's what's really useful about trim. We got rid of both excessive empty spaces. So it's going to look a lot nicer overall. Now, yes, you'll still get the 2 characters here on Queen and Jack, but that can be really nice that preceding space when our first card is a single, as like one of the base values, numerical values, it can make sure we don't have that extra random space in there. So
Trim is also good for when you're making login names or making usernames, because you can, if people put extra spaces
Yes.
for or back, you can trim those off and make it.
100%.
nice.
That's one of the main reasons, actually, I'm introducing trim to you guys early so that when we get to those items, I can use it again. You already know what it is. It's very, very important to use those on passwords and on email accounts and usernames, 100%. People will accidentally hit spaces. I know Android for the longest time, I don't know if they still do it, but when I was doing Android development, when you use the predictive, when you use the autofill method from Android, it will automatically add a space after the word, where Apple doesn't. So someone does the autofill on Android to put their email account in for the login, it will add that extra space. They use the autofill to enter their name. When they do their last name, they'll get an extra space at the end. So you'll get a lot of these extra spaces. And so you need to make sure you handle those in your production level projects. So, good stuff. Like I said, I was going to bring that up more later, but good you mentioned it now. So we can just kind of plant the seed. So we go. We got our add card display hand. We can see we are able to deal out a blackjack hand. Let's go ahead and hit a couple times, make sure it works. We're going to hit twice. Yeah, dang it. Yeah. And then we'll display again. Let's see what that looks like. And see if we're getting 4 different cards each time and that it looks on one line. That looks good. Looking all right.
You went over.
Yeah, well, I'm giving myself 2 cards. That's not an easy thing to good. 3 cards is the average you have in a hand of blackjack. So very rarely do you go above 3 hands. 3 cards.
Yeah, like
so.
21 on the other one because but the extra ace just took you over.
Yeah, of course. Are any of these actually doable? Nope, 25. Yeah, trying to see if I can get a 4 card to actually be safe is near impossible. Jesus Christ. Yep, nope, not gonna happen. I think we're just gonna give up. Wait, 8, 9, 10, 1. Oh, I'm over by 1.
Yeah,
That was close.
you had
22.
a similar one like that last time. You had 6 and 5 and 11, and then you
There
had
we
the
go.
ace and queen or something.
All right. So let's do a get value next. Now this is the next one we care about. So this is the next big one that's kind of important. And what time are we at actually? No, actually, I think I skipped that one. I'm gonna give you that one as a. Oh no, it's already Tuesday. Maybe not. And let's think about these for a quick second. So hit, stand, double, and split. So these are actions for blackjack. Are these actions specific to the hand or to the blackjack game?
It's a blackjack game.
All right. Let's do a little. So that's already giving it 1 point to maybe belong in table or game, maybe not hand. When I'm hitting, what am I actually doing? When with the action hit, what actually happens? When a player says hit, what happens?
One card from the deck goes to your hand.
All right, so we have to draw a card from the deck. If we look back to our hand class right now, if I was to do the hit method here, what would I need as a parameter?
Well, what's interesting is that the hit could be add card because you're just adding an extra card.
Right, I could call add card on hit, but then
Yeah.
I would need to make sure that somewhere I can trigger that draw though.
Right.
So if I wanted to trigger the draw from inside the hand, I would need the deck class in the hand. So that's another reason to maybe not do the hit method inside the hand, but maybe handle it in the game, right? Because the game has access to the deck and the hand, right? So the deck has access to both items that it needs in order to do this. So the hand can tell the game what happened. Or at least again, the hand through the player can tell the game what happened. So I think we may actually move these over to either table or games. We're moving it out of hand no matter what. So get back. I think I'll start it off for you guys. All right, we'll do hand. Gotta get value. No, let's do that because you guys can always do the hacker rank stuff. It's fine. I want to get through more blackjack because we didn't get through as much as we wanted to. So public string display value. The goal here is going to go through our cards and get the blackjack value of each card, right? And add that to a total. That sound right? What is level 1 of this program, of this method? First, I'm going to do this. So int score 0. What's the simplest version of this that we can start with? That isn't necessarily accurate, but it starts us off. What do we think? Come on. Like, what's ground level here?
Cliff, does your cards have numerical values or are they strings?
Let's go back for a second. Let's look. Our values seem to be ints. And if we get value, we have a get value that just returns the int by itself. So we have that. I'll move that over here for a second. So you can have that on the side. Hide that down. So we do have a way of pulling the value from the card. The numerical value. So again, what's our most basic version of this?
So we need to sum the values.
So what do I need here? I want to get all the cards again, right? So what do I need to do? Sanity check, people, come on.
Just to loop through the cards list and then use get value for each item.
Similar to what we did in display hand, right? We want to loop through the cards again. So for card, cards. This time that we're going to do score. And as you said, we're going to do the card dot get value. Now, is this going to be accurate?
We still have to check for like the face values and stuff.
Yeah, we're not really evaluating them in a sense of score, like two string. We're not really, we're not really converting this yet, right? We're not really handling the cards in a blackjack sense. We're getting the number of the cards. So ace is starting as 1, jack is gonna be 11, queen is gonna be 12, and king's gonna be 13. But at least this is a starting point that says, are we at least tabulating all the cards? So if we go back to our main class and just do under here, we're gonna do s out my hand dot display value and do that twice just to see, are we getting the total of the cards as is without doing any sort of like logic yet? Because if I can't do that, if I can't even at least get the normal values, why am I going to do all the complicated like blackjack logic, right? Play, let's see. And 3 is 12. I didn't get any special cards. God dang it. What a start. That looks right. Wow. What's the odds of that not getting a single specialty card? There we
Alright,
go.
we checked it.
Go ahead.
It's definitely a bust.
Yeah, so this is telling me I got 20, but this is not supposed to be 20. That's supposed to be what?
18.
18.
Same thing here. This is giving me another 13 added to my total. So we're definitely off on this one, right? There should be 14 plus 18, not what we're getting. So that's of course the first. So if we think about it, that's probably the easiest next thing to change, right? Because we have 2 specialty cards, right? Technically, we have 4 cards that are special, but 2 types of specialty cards. What are the 2 types of cards, special cards?
Base cards and
Yep, ace is the one. And then what else?
base cards.
And the face cards. Yep. So you have the face cards and the ace cards. And so those are specialty cards. If we had to look at these, how could we, so if you think about it, what is special about the face cards?
They're all worth 10.
All right. What's special about the ace?
It can be 1 or 11.
Which one sounds more complicated to code?
11.
Thank you for saying that one. I was waiting for the smart ass to say the face cards. I'm like, ah, damn it. So that is true. We have one of that one. So in this case, we want to be able to take that onto challenge. So let's go back to our main hand and let's add in that specialty there. So before we add it to the score, what we should probably do is get the value and then do something with it if we need to. So value equals card dot get value. And we're just gonna use it in a switch statement again. Keep having fun with that. You know what I'm gonna do? I wonder if I could do case. Usually can do this 11, 12, and 13. I wonder if you need commas though.
Yeah, you need commas.
That's what I was thinking. I was like, it might be commas.
I think you can only do that with the arrow stuff.
Yeah. And the other one, you just have case 11, case 12, and case 13, one at the other. You would do it like this, case 11, case 12, case 13, because what normally happens is you would have the rollover effect. Because none of these have breaks, it would just roll into the next case. So then all three of these would roll down into case 13, you would handle it this way. So that's the normal way of doing it, but since we have access to that shorthand version, we use that one. In this case, we're just going to do score plus equal default. And so if we don't get one of those, what are we going to do right now?
Four plus,
Yes.
plus equals get value. Card get value.
Thank you. I was gonna say, we don't need to run the get value again, do we?
Oh,
Yeah.
oh, value, okay.
Yeah, we don't need to run the method again. We can just do
Alright,
the
right.
value. Yep. Score plus equal value. And again, we return the score. Let's see if that makes our item a little better. Hey, look, we got 14 instead of 15 because Jack is an 11. So we got that. That's good. Jack right there. And then that worked. Let's do it again one more time. 9, 10, 11, 12, 9, 11, 15, 16? Yeah, 16. Oh, wait, what? Hold on. Am I doing it? Is that right? Yes, that's
Yeah,
12
16,
and then
10.
plus 4, 16 plus 10. Yep, okay, go. Losing my mind. All right. So now the problem is though, we do need to figure out how do we handle the aces, right? And my notes on how I handled this again last time. So I'll make sure I remember my way of doing that. Where's my notes? I think I closed them accidentally because I had to clean up some tabs for the presentation. Second.
Could you use a if statement for the 11?
Yeah, the main thing though is handling two aces, right? How do we handle if we have two aces? So yeah, the first case, yeah, we can do the simple one. We can start with the simple one saying case 1 and say it's equal to score plus equal 1, right? Could start there. But how do we make sure we handle multiple? Remember, I'm pretty sure I remember how I did it. But I
I think
just
you
want to double
base
check.
it on the total value of the hand.
That's
Could we do
possible.
an if with the total score? If it's more than 21, then considers the ace as 1. Otherwise, always considers as 11.
Huh,
That's what I was
good
thinking.
idea.
But
Yeah,
Cliff
but then
is
what
right,
if you have
though.
more after that?
Sorry,
But
what?
Cliff is right. What happens if I have two aces? I can make that 12.
To an extent though, so if we're
It would be
slow,
12 only.
ooh, yeah, and again, we would be baking it on the total when we get the ace, right? So we need to know if we already have an ace too, right? Where's my stupid thing? Where are you? Okay, where'd my stuff go? Why do I feel like I'm missing something? Is it old? That's not fun. Second, where's my repositories? My notes. These are old notes. Still old. Wait, what? Where are these usually stored? One second, buddy. Where do we store this stuff? I do this, I do. On here. Great, I gotta remember how I did that now. I didn't find my notes on that, but. Oh, I remember how I did. So there, I do remember, I'm pretty sure I remember how I did it now. Yeah, I was thinking of something different than that. So yeah, that threw me for a loop. I think I remember how I did it. So. We have two scenarios. So yes, one thing we do, of course, is check to see if the current score already is over before we add, if we would add the 11. If adding the 11 sends us over, we can then undo and go back to 1 instead, just add 1 instead. So you could do a ternary expression here saying score plus equal, score plus 11 greater than 21. Then I'm going to add, if it said, if it's true, if adding the 11 is going to send us over 21, we're just going to add the 1. Otherwise, add the 11, right? The downside of this is if I have ace as my first card, there's almost no way for me to be over 21 with that one. But then the next card, which is the king, could put me over, right? So if I switch this for a quick second, let's save this for a moment. Save for a second. Let's switch back to the rig deck for a second. Play. I'm going to give myself the ace. So 1, 1. I'm going to give myself a king. So I'm going to do a 13 and 1. So I get my ace king, I get my 21. But I'm going, and now again, we're auto hitting twice. So I'm now going to give myself a 5. 2 and a 2, 2. And this should not go over, right? But notice it's still going over because my condition only says at the time of calculating the ace, if I'm over, reduce it. But at any time, I'm not going to reduce it afterwards, am I? You need to make sure at some point.
You have to constantly check.
You
if there's
only
an ace
check
in
at the
hand.
beginning.
Check it after the fact.
Hold on, one more time. Try that again. Sorry, what's that? Try that again.
My thing was you would have to constantly, if there's an ace in hand, you would have to constantly check just to make sure that that ace could change. I don't know
Close.
what Mike was saying.
So, yeah,
I
Mike,
was
what were you
saying
saying?
you would check to see if it's over 21. It would be a 1 after the fact, after you
Yeah.
calculate the first time.
So one thing we could do though, if you're over there sitting and you're adding up your cards on the table and you're forced to only look at one card at a time, you can't look at the other. So we flip over one ace, I see it, and I'm going to flip that ace back over to be able to flip the next one over. That's kind of what the computer is doing, right? The computer can't memorize what it sees. So you can't memorize in your head that you saw an ace unless you have some sort of memory allocated for that. Remember that how a computer works. So pretend you're a computer yourself. So you flip over, so not whiteboard. Whiteboard time. I have my pen already installed and ready to go, so we're good. Here's
So you have to have kind of a flag to say you have an ace.
What's that?
You have to have a flag to say that you have an ace in the hand, so you know. if you have
Maybe,
to
but
flip
before you
it.
get to that, I want to help people see that train of thought to see that. So we have our cards over here. So we have 1, 2, 3, and 4. So the first card we flip over, that's gonna be an ace. So we of course add 11 to our score, and then that card gets flipped over again, and we don't know what that was. Where did my tools go? I want to make sure I can hit my eraser button. Hold on. Coming. There we go. So erase. And the next card, of course, we're going to say is we'll say 7. And so I put them in bad spots. So we'll move the 11 down here, actually. So that is right where my tools are. So we're going to add the 7 to the 11. That puts us at what?
18.
18. Yeah, we probably save, but let's again say that we did hit. So we hit again, and this time we get. I'm gonna have fun with this. Well, no, we'll start with the simple one first. So yeah, we'll go ahead and say we got a 3. I'm just gonna put us, that won't put us over actually. So hold on. That's at a 5.
So
Cliff,
Cliff,
five.
instead of saying if it's a 1 or an 11, you could just say if it's over 21, minus 10, if you have an ace in your hand.
Again, I need to make sure I know to check that only if I have an ace, 'cause I would need to have an ace before I check that, right?
If you had a Boolean.
There it is, right? Right, because as you see here, in the computer doesn't memorize I have an ace, but I'm sure you guys are in your head, you know I have an ace, right? So as far as the computer is concerned, as soon as I add this 5 to this, we get that, what is it, 22, 23? 23. The computer doesn't have any problems. He's like, that's fine, I'm okay with this. I would need to know that that I have an ace to say, oh, hey, I went over, let me reduce,
Yeah.
right?
Go
And
on.
so in order for us to do that, we need to have some sort of flag, has ace, right? Has ace, and I can set that to true. As soon as I saw one, and I can say, as soon as, if at any point when I add a score that goes over 23, I can just instantly remove 10 from it. Minus 10, that's not a great 10. Minus 10, making sure I'm down back to 13 and not 23. Yeah, my funny bone. Ow. And so this could be a great way to handle things. So that can definitely handle at least the 1 ace. If I have 2 aces though, let's see what happens there. So I have an ace, ace. What is ace, ace? If I do 11, that.
It's 12.
Yeah, it would always be 12.
Right, so I'm automatically gonna remove one of them automatically immediately, right? So I still only have 1 ace if I use this. So I do ace, ace, that's gonna be 12. I still have an additional ace that I can reduce still though, right? So this seems to be able to handle a double ace, doesn't it? That flag can handle this scenario. And that's the thing, even though I knew for a second, like, oh, the has ace Boolean can handle a single ace, let me first check and see if I can handle the other scenario with the same solution.
What if you had 2
Well, I
aces
wasn't
and then
thinking
you
of-
hit
I
and got a
wasn't
king?
Has ace. I was thinking maybe the card itself could have a Boolean like is ace.
The thing we would do I wouldn't do is ace, because again, that's only specific to blackjack. Only blackjack cares about this, right?
I mean, I think other card games incorporate that.
Potentially, but again, wait.
Like
I don't think the
poker,
card
aces
needs to
are
know
high,
this.
right? In poker.
True, but in certain games, aces are 1. That's the thing. So it would definitely be, I would definitely lean it more towards the game. And that's why our hand class is in our blackjack package. So this hand can be kind of targeted towards blackjack a little bit. But even then, if you're going to argue that the ace card should have an is ace Boolean, then why don't I have an is 1, is 2, is 3, is 4, is 5 on all the other cards too, right? And that's
Well,
where you're starting to get
when
a
I
little,
felt blackjack on my own, I did a Boolean ace is 11.
oh,
Because then when you change the ace, it keeps track of that.
I can
That way
see
you
that.
get more than 1 ace. And
Yeah.
then you go over, like they could both be a 1 instead of one always being an 11, then the other one being a 1.
Well, in this case, 1 is always going to be 1. There's never going to be 2 11s, because 2 11s instantly puts you at 22. So that fails. So that's one of the benefits of how blackjack works, is that you never have to worry about having 2 11s. There's no way, there's no logic way for that to happen, that you have 2 aces at the same time being tracked. You only ever have 1 ace at 11. Every other ace after that is automatically a 1.
Yep.
And so that first logic we have is good. And so the idea here is that if we have an ace that is saved as an 11, so if any ace is treated as an 11, has ace becomes true. If we ever get an ace that is treated as a 1 immediately, we don't trigger the flag. The has ace is telling us we have an ace that we can remove. So I guess you could say has ace 11, or has 11, or has, well, however you want to word it.
Ace is 11.
So yeah, has ace as 11, or has ace is 11. That's fine. If that makes it more specific for you, makes you understand it better, I'm game for that. My idea was that if has ace is true, that means I have an ace that I can reduce. That's what has ace meant to me, but we can do has ace 11. That's fine for me.
Just to mention other card games that have for aces, the ace low would be 1, but then if you had an ace high, that would be 14, because that would be after.
Yep. Yeah, so every game has special scenarios with certain cards sometimes. So definitely be aware of that, that we want to make sure that we're definitely making sure that the items that are game specific are in the right package. So right now our hand is in the blackjack package. We do this. At the same time though, again, I could make sure that this is lessly coupled by, instead of just saying display value, I could say display BJ value for blackjack. So I could make sure this is the, did I stop displaying? I did. Hold on. I just noticed the green border was gone. And you guys weren't visible. So.
I have a question. Does that
And that
work
makes this
for
less coupled.
2 aces and a 10?
Let's test. So back to the whiteboard. Actually, no, I can do it here without the whiteboard. I can just do the annotate on the black here. So let's say we have 3 cards. So we have ace, ace, king. So the first one comes in. Our calculation goes here. So we're going to go ahead and add 11, and that'll make our has ace equal to true, because we took in an 11 as an 11, an ace as an 11. We then bring in the other ace. We say, okay, if our score plus 11 is going to be over 21, it will be. We will count this ace as a 1 immediately. That puts us at 12, right? And that does not trigger our has ace because we didn't reduce our 11 yet. We didn't trigger that because now we would test and say, hey, is this over 21? Nope. So we don't use the ace. So we can keep that as is. We hit, we get a king. So now we have 12. We're going to add 10 to it. That puts us at 22. And then we check, hey, is our total over 21? Yes. Do we have an ace? We do. So now let's deduct 10 from it. We're back to 12.
So you bump it up and then you bring it down again?
Yes. Because we can't add that additional logic in the current system we have. I need to get rid of my annotation now. So now the one thing I'm curious about is can I, with this short syntax, add a code block here? Can I do that? I think I can. It seems to allow me. Cool. I'm also going to update this a little bit and say, instead of doing it like that, I'm going to do that. Yeah, not value. No, not value. Oh yeah, I can switch value. It's an int, right? Yeah. Value. Update value based on this. So I'm going to change value to match whatever I need it to be. And I can do if value equals 11. I now need my Boolean that we said before, right? What do we want to use, people? What do we want to call it?
Ace has.
Always start with has or is. Remember that. It should be a question.
Is ace
Human speak.
has.
Is ace has. No. You don't like it.
Let's just go with it. Let's go with some nice thing. Do I actually have an ace is the
Okay.
variable.
You are being evil to me.
Nice and
I
low.
like has ace, or yeah, I like has ace is a good one. Yeah, I know. No, I like has ace. What you put in originally is
It was has ace or has ace 11.
yeah.
You like that one? The has ace 11 or the has ace?
I like with 11 in there. Keeps.
For me. And we're going to default it to false, by the way, because we
Well,
don't.
not has ace. Then you would have to switch that. Doesn't make any sense. Make it is ace 11.
No. Is talks about a specific item. We're saying that our hand has an ace right now.
Oh,
I'm going to
I
say
mean,
have
it has
ace.
English.
Yeah.
it just has
But
bad English
You
saying
can
has.
say if
11.
has ace. And you're going to say if I has ace or have. You can say if have ace, do. That's fine. Have ace. That's fine. I just
Have
say
high
saying have
ace.
because
And we're specifically checking for
That's a
those
good
that
one.
are valued as 11 right now, right?
Yep, have ace 11, yep. With
John,
this,
John suggested high ace. I kind of like that too.
that's fine. What I can do now is after this process of adding it to the score, I can now here outside the switch statements, I can now check to see if I'm busted and I have an ace, right? So at this point here, I want to check to see if I can save myself with an ace before I return that value because I'm not done yet. I can change my value still. If my score is greater than 21, what else do I add after this? What's the conditional? I give you the easy part. What's the second half?
And have ace 11.
Good. I have an ace that's 11. I can do score minus equal 10 and have ace 11 is now equal to false. What's good about this is now we can test to see that if the, let's do a quick thing here. Ready? I'm going to do one more test now to see if this works. I just thought of another one. So we're going to do,
Don't we need to make have ace 11 equal true at some point?
didn't we? Oh, I didn't actually type it. I wrote the variable, but forgot to actually add it here. Thank you.
You setting the value to score?
What's that?
Are you assigning score to value?
No, that's a, oh wait, where'd the ternary go? Oh yeah, the ternary is there, right? Oh, hold on. Bah. I deleted that. Why did that come back? You're right, I was doing something like that. So that's what I'm gonna do. Do the ternary expression, I'm gonna set value to either the 1 or the 11. That way I can then test on it. And I still need to add it to score though. So I didn't do that though. Oh, right. Actually put the value in it. So there we go. That's what we should be doing. Yeah, you're right. I don't think I actually, I was gonna actually get the score in the value after I added the result of the ternary. So that would have been a bad problem. So nice catch.
You're still
Good
adding,
catch.
aren't you still adding the score to the a 1 or
No.
11 up there?
Ternary expression.
Oh, okay. Okay. I see that.
Yeah. Ternary.
Okay.
If anyone doesn't understand what this is doing, please let me know. I can switch it to an if statement. If you do not understand a line of code, please ask me about it. Do not let me just run away with it. I'm hoping that by now everyone here can understand what the ternary does. If you do not know what it does, speak now or forever hold your peace. 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 I think we're good. All right.
After the question mark is true or the
True
next-
and then
Yep.
false. Yep.
Yeah.
Yep. See, you got it. Good. All right. Awesome. All right. So just to clarify, make sure we got everything here because apparently I forgot some stuff. So we go for the value. If we have an ace, we're going to go ahead and store the current value of that ace based on our current score. So if our score plus the normal value of 11 is going to put us over, we actually want to count this ace as a 1. Otherwise, if we're safe, we'll count it as an 11. If we count it as an 11, we want to mark that we have an ace that we can reduce if necessary. And then last but not least, we're going to add the current value of the ace to the score. And to that, that will, of course, break because we don't have to worry about the break here. But that's going to go down. If at any time after we add something to our score, if that score is going to put us over 21, and we do actually have an ace that we can remove, we're going to reset that ace to 10, remove that ace from the tracking, and then return that score. Let's do some, go
Is
ahead.
there any way that you could, on line 34, where it says 11, could you also say have ace 11 equals true there?
Kind of because of the semicolon, but I don't know if I can put it here because that's going to be 2 things of code. This is trying to do an assignment there. So I would need to do the have ace 11 true here, but I don't know if I can do it here.
Okay.
Yeah,
I was just
that's,
curious.
yeah, ternary expression, the true and false of the ternary expression can only handle a single instruction.
Okay.
Yep. I could make a method that does 2 things that I call and then returns 11. So I wanted to, I could just make it a method that says get 11, but then I would have to find a way to then set this value in another method, and then we have to worry about scope. So I wouldn't recommend it. This is fine. The only other thing I could do instead of doing the ternary expression is just do an if score plus 11 equals 21, value equals 1, score plus equal 1, or score plus equal 11 and have ace equal true. So I could do it either way.
I was just
Yeah.
curious if you could do it with the ternary operator as well.
Nah, ternary is the true and false makes a single line of code. So single execution, a single executable, not a block. Okay, so that should be it. So let me do one more quick test on this. So let's do our ace and our king. And again, we're going to be stupid with our plays. We have 21. I'm going to take a 2.
Do the best play.
Yeah, I know.
1 ace,
We're
1
gonna
3,
hit.
1 ace, 1 6, 1 ace, and 1 9. That's a
There you go.
21. It's
So
the
ace, king,
longest way that I
2.
found.
21. Oh, okay. We'll do that one in a second. So you have ace, king, 2. 21. The 2 is going to put us at 23, which is then going to cause us to get reduced to 13. I'm going to add another ace, and that's going to bring us up to, that'll invalidate and keep us at 14. So now let's do yours. 'Cause I think I liked yours. 'Cause I think it's going to have us go up and down, up and down, up and down. So hopefully. What I want to do is use an ace, but then get another one that I can save. But I don't think I can actually do that because once you use one ace, you can't use any other aces. So what was yours again?
Ace, a 3, and then ace, a 6, and ace, a 9.
Oh, just
Plus what?
And then ace, and then 9.
9 again. Okay. So
Yeah, just do
starts
4
at
aces.
11. Hold on, we'll do that in a second.
Just do 21 aces.
Ace, so 11 plus 3, that puts us at 14. So it's still good. And we have our true over here. We'll just mark it as a T. We add another ace, but that's going to get marked as a 1 automatically. So we're not going to use this ace yet. And that's going to put us at 15. The 6 is added to this is going to put us at 21, which is like we should stop, but we don't. So we're going to go ahead and get another ace, which again, this ace is going to be treated as a 1. It's already going to put us over. That's going to put us at 22. And then this item is going to get caught because now we're over and we have an ace, which is then going to bring us back down to 12. And then we add the 9, which then puts us at 21, which seems like our code should work. And what's fun is if we do the rig deck, we can actually redo this. We just need to make sure we have enough draws to do this. So let's try that. I actually want to try this one. This is going to be interesting.
Maybe backwards so you don't get the 21. Just ace 9, ace 6, and then ace 3.
Yeah, I like that. I actually like that we're going to get 21 once and then 21 again.
All right.
I'm okay with that. I just want to make sure it works.
You don't
So-
draw on a 21. That's
I know you don't, but that's why we're
That's
testing. Right now we're testing. So
yeah, that's fine.
we'll draw 2, we'll display the hand and value. We'll draw again, and we'll again display the hand and value because I want to see it every single time. So you know what? We're going to display the hand and value after every draw. So this is going to be the ace, the 3, ace, the 6, and we need 2 more. So I'm just going to copy these 2 lines, these 6 lines. There we go. Let's test this thing in action. Play. First one is going to be ace, spade. Get the 11 like we expected. We're then going to grab a 3. I don't care. Heart, fine. Got the 14 like expected. We're going to get another ace. That puts us at the 15 like we thought. Good. Let's grab a 6. Diamond. That puts us at the 21 we expected. Let's grab another ace. Drops us back to 12 like we expected. So that did trigger like we expected. And notice we went over after the, so we did count as 1 and then we went over and we used up our free ace that we had. And then let's give us another 9. I'm gonna give us another ace just to make sure that this ace won't trigger and then an 8. I'm gonna do an ace and then an 8. Oh, I can't do that actually. Dang it. 9.
Then we do 21 aces.
There you go. In our rig deck, we could definitely do that in our rig deck. Any other testing we want to do with this? Any other ways we want to make sure we can draw up to 6 cards? Any other scenarios we want to try out?
We can't do 21 aces because there's only 4 aces in that deck, right?
Not in a normal game, but in our rig deck we can. Because
Oh,
I
yeah,
can
I
keep
forgot.
creating the same card multiple times. I can totally do that with our rig deck. I can do.
Spam aces.
Oop, I need to be in there. 1. I can just give myself a bunch of spades, ace of spades. There you go. So I only got the 16, which is what we expected. 5 of those aces were treated as 1s. The first one was treated as an 11. All right, I'm open to any of the tests. You want to throw any cards at me, or does this seem like it's going to function like we want? So my main point for this one is that I really wanted to show was that concept of looking at the cards one by one and reminding yourself not to remember other cards you had because the computer can't remember those things. The only way you can remember things, the only way a computer can remember things is they allocate memory to it. And that's something we do subconsciously. We don't have to ask our brain, hey, can you reserve space for this and put it there? When we see something, we can easily just put it in our memory naturally. It's just there temporarily in short-term memory. We have this instant short-term memory thing that anything we see and do is instantly recorded. We can't do it in the computer. So sometimes we have to remind ourselves that computers can't do that. Just because it saw it once doesn't mean it knows it's there permanently. We have to have some way to know that it's there for later use. We have to set aside space to know that. And that's where one of those things of thinking computationally can be a little difficult for us because that's how a computer knows works. So it's very helpful to look at things like that. And what we just did, we're forcing ourselves to look at one item at a time and then delete that item from our screen, and so that we don't see it. And so when we know we need something, we need to be like, well, how, if I say, okay, I went over, I need to be able to remove that ace, and I need to look at the whiteboard, and as a computer, looking at what the computer has available to me, because what I wrote on the whiteboard is what the computer has. How do I know I can remove the ace? I can reduce that number. When we first looked at that whiteboard, there was nothing on the whiteboard telling us that we could take that 10 points off. And that's what hinted at us, oh, I need a Boolean so that I know I can do this. I can remember that I have that ability to do this, right? And that's where the whiteboard can really come to help, because it can help force you to pretend you're a computer and really help you to look at things one by one like a computer does, because it looks at things one by one. Unless I have two variables or two things storing multiple things, right? So that's where it really helps to be able to walk through the code or walk through a problem like a computer. You know what you can do, but how do you get a computer to do a similar concept? And you really have to expose how your brain works. That when we see that ace, as we're counting through the blackjack system, we remember we have that ace. So as we go through the other cards and we find that we're going over, we can then switch it.
So I have nothing wrong with what this whole logic is. It's 100% sound. But I do have a list though, and I could actually iterate through the list to find out where all my aces are, because I do have a reference of my hand, and I can actually tally up after the fact. But I think that's a lot more work than doing.
I'm gonna say, yeah. I'm wondering what the O of N of yours is.
Yeah, no, I realize that, but you're saying the computer doesn't know. But yes, we kind of knows, because we have an actual list and to know what we have. Yeah. So it isn't like the cards disappear. It's actually
true. But again, the computer can only look at each card one by one.
Yeah,
I had multiple aces. I have to remember which aces have I used or haven't used yet.
No. That's why I stayed in the beginning. This is like logically sound and everything. But I'm just saying.
Awesome.
No, that's why I pointed that out in the beginning. But I'm just saying that we do. But we could look through the list for how many aces, and we can generate that. But yes, it'd probably take a lot more work.
Yeah. So now this looks fairly sound, right? We have a nice hand class that we can now actually kind of play blackjack with. I can't play it live, like I can't ask for a hit or a stand or anything like that, but I can build blackjack hands and tabulate them correctly. And that's really important for us to be able to do the next part. So now we're ready to bring in the actors, which we are going to do tomorrow because we're already at 9:11. That's ironic. It's already 9:11 right now. So the one thing I'm gonna do is I'm just gonna build quick the actor class, the actor interface. That's it. So we're gonna put the actor class in blackjack, because again, the actor package will accept any actor interface. Let's put the interface here because our blackjack system needs it, but we shouldn't have to include both blackjack and actor in order to use them. We can bring the blackjack package in and then bring any actor class that can utilize our interface, as long as it knows that it's there. So we're going to disconnect the actor from the blackjack, but make sure that the blackjack knows it needs actors. So new Java class interface actor. Oh, fancy. Let's look again at our plan of attack. So actor has a get name method, so we can display the name. What data type is our name most likely? Just for sanity check. Thank you. The next method we had was the get balance. Data type for that.
Int. Oh, wait, balance? Yeah.
You're right. And I forgot to do get on the name, so 1 second. There we go. Yeah. Anybody else awake, or is it just Keith awake right now? And Jim.
Hey, wait. Interface doesn't need public, right?
Right.
Yeah. So I did this one already for you. Dang it. Bet.
Totally awake.
All right. All right.
Doesn't mean to be awake.
Bet. And then last but not least, we have get action. And now let me just do this, get action. Any ideas of what the return type for get action might be?
I don't think it needs public.
What's that?
I don't think it needs public if it's an interface.
You're right. The interface doesn't need them. I'm just so used to habit. I'm just habitually a typer of that. It's unnecessary, but it's not going to yell at you if you do it. So. Yeah, you're right. It's definitely not needed. So get action. What data type can get action return? There's two options of this.
Player?
No, it's not going to return the player. This is going to actually return the action of what the player wants to do. So is it going to return a string, a number, a Boolean, a float, a double, another data type, and another action, another
An
class?
integer?
Integer, and what else was it? I heard another option.
Big decimal.
Big test. No.
Hold on. No.
That's our mutant Freddy.
Actually, if you really wanted to go like really good, you can go with byte because we don't have any ones to work with.
Sure, we
But
could,
we
so,
could use int though.
and there's a bunch of options for this. So really we can do anything we want because the main idea here is that we need to know we're going to run a condition on that to make sure we run the right method, right? So if we think about the logic behind this, whatever they give us, we're probably going to run a switch statement on it to then decide what method to run to actually perform the correct actions. So what are the best data types to use on a switch statement?
Int.
All right, int. And for Jim's argument, we could of course go byte because are we ever going to have more than 256 actions? Sorry, 255 actions on a game of blackjack? We are. Freddie, give me 10. How about that?
Hit once, hit twice, hit 3 times. You want to be preemptive about it? You can see the future.
Hey.
Stand, sit, roll over.
Think you're using blackjack with a dog named Blackjack. No, in this case, yeah, we could also get away with char. So char would be fine. Int, byte are fine. I wouldn't personally recommend string. We know the string being evaluated is not great. We have to use like the dot equals command and stuff like that. So I probably wouldn't recommend string in this case. But could you do it? Yes, it is fine. You can get away with it. Just understand that Java doesn't like it. It's a memory intensive item. So we're going to expect to either get an int, char, or byte. What do we want? We want int, char, or byte.
Let's just use byte. I don't feel like arguing about it.
I am perfectly fine with ints because like if you were dealing with IoT, then fine, go ahead and use byte. I would recommend that. In the systems that you're coding for right now, the difference between a byte and an int, the memory you're saving is negligible. You're not running this item or reserving that level of memory thousands of times where you then have to worry that you're storing that much money, that much items in memory. Like I said, though, if you were getting into like IoT stuff or blockchain stuff, then yes, I'm going to care more about how much memory you're using. Right now, the stuff you're coding, the amount of memory you're reserving right now, I don't really care. If you use ints, I don't care. But yes, we can get a byte back, and that way we can do a switch statement on the byte to see what we get. The only thing I got to wonder about, though, is let's do a quick little mini test, because I'm curious now.
Oh, because
It's not yelling at me, so it will auto convert, it seems like.
Oh, I know you.
I was just wondering, is it able to auto convert or check that automatically? Unreachable, yeah, that's fine. So yeah. And can we store? And for anyone, I'm curious. So for we'll parse int. Do this quick.
Doesn't parse int return a int?
yeah, you want
That's what I'm wondering
to
about.
parse byte.
Do we
though.
have parse byte?
I believe so.
Is it byte.parse byte?
Oh, because you can.
Okay, we do have parse byte. Yes, we could do that. So that's fine then. Okay. See, yeah. All right. So just be aware that if we use byte, we need to use the right parser. So definitely be aware of that because we're going to be pulling information from the user, right? One of our actors is going to be using the console. And so the data is going to come in as a string. So we need to make sure we convert the string to a byte, not an int. But just to be curious, if we tried that, is it going to yell at us? Yeah, it won't auto convert because it argues that there's a potential data loss. I can, of course, typecast the result as a byte, but it's going to warn me probably at some point that there's potential data loss here, that I could lose data. It's not going to warn me now because it knows what the result is, because it can see what the string is, but I would assume that that's going to be a problem because we're reducing the amount of bytes we have. And so if there's any excess numbers, we're just going to lose them. So there's potential data loss. Whenever you're going from a larger byte value to a smaller byte value, there is a potential that you're just going to lose information. That a certain number of money, if your integer here is larger than what the byte can store, it's just going to lop off those bits. So, all right, cool. So we can do that. That's fine, man. Awesome. Those are just a couple of things I wanted to test. And again, that's me. I didn't know if those are things, and that's something that you should 100% do. Don't just assume your stuff's going to work. Testing, like, okay, I expect this to work. Can I do this and this and this? All right, cool. I can use it. So that's fine. For me, that's one of the best ways to grow your knowledge of your language. Just change things up, test things, play around with the code, make sure things work a certain way. So there's our actor interface. And one thing I want to check though now. So let's think for a quick thing though. So get bet is going to ask the user for their bet. Do we need anything sent to it to ask the user for their bet?
How much?
We mean how much?
Well, no.
The wallet, maybe?
We might want to send what they have. That might be a not bad idea. So yeah, that makes sense.
Well, that's what I'm saying. More like, yeah, like pass through the bet, like passing it through, like what it is.
Does the actor not have the wallet on himself?
Good catch. I was going to leave that here, but we're going to catch that later, that the wallet is in the actor. And so we wouldn't need to pass it. I was going to leave it now because that is, I figured that is a safe thing to start with and realize we might need that for the get bet. And then later on realize, oh, we already have that. But yeah, technically, if we remember correctly, the actor has the wallet, right? So player has their balance already. So we wouldn't need to pass it to the get action because it's inside that class. Make sense? Good catch, Freddie. I'm gonna leave it so that people can catch that on there naturally later. So we're gonna keep it now because we do need that for the bet. We don't know yet that the actor has it, technically. Get action. Is there anything that the action is gonna need? Any actor, like player, the dealer, a card counter.
I'm not saying anything. Someone else can.
I say James has already coded this once, so he's trying to be good and make sure you guys are thinking.
Yeah.
So let's think. So for the player to make a decision in blackjack, what do they need? In order for you to make a decision in blackjack, what do you need?
Need some
You
cards.
right now, you need to see your cards, right?
Yeah.
Now let's ask the same question that Freddie just kind of pointed out. Does the player have access to the cards directly?
Oh yeah, you have the hand. Not
Right, the
player
hand, the
doesn't
player is
have
owned by the hand, so we would have to pass that through. We would need the hand here, so. I will say, just for the record, if we did want to do the card counter, we would need a get action overload of table as well, so. Or hands, in other words. A list of all the hands, because the card counter needs to see all the face-up cards to get the values of each face-up card so we can count. And that could either be a way of getting all the cards on the table. That could be the table itself. So then we can that the card counter can iterate through it. There's just some way we need to get all the cards. And even then, we could argue that if we wanted to, in the get action for the player, we could still send the table so that we could print the entire table, right? So the get action could trigger the table print. So we could still maybe use this one, but we definitely know that the get action at least minimum needs the player's hand to be able to make an action, right? We know that we at least need to be able to print your hands that you can make a decision based on what you have. For a lot of the other systems, it might be nice later on to be able to send all the cards on the table as well, so we can print those out, display the table first, then display your cards, and then ask you what you want to do. So we might end up using this one as well, right? We'll keep it like this for now. That's pretty much how you can go through your process of, and this is going to be angry with me. I thought it does not need to import the hand. Right, you don't need to do that. I forgot. The interface, the implementer will bring in the other classes that exist. I forgot about that. Yeah. So that's another big advantage of interface, is that the interface is not going to import any classes. If you identify a class as a parameter, it's going to allow the implementer to decide what class it imports for that. So one child of an actor can import a hand class from one package, and another actor can import a hand class from another package. So that's one of the other benefits of the interface that I forgot to mention. It's one of the ones I can forget a lot of times. So that's what's really good about interfaces. That the interface can identify a special class, but it doesn't have to be that class that you already know about. And that's another benefit of this system right here, is that our actor maybe even still could go into the actor class, actually, because the hand over here doesn't have to be defined here. It can be defined by the players, but no, I have to like it here. Yeah, that'll be fine.
Is it because of the same package?
Oh, wait, I think you're right. Yeah, that's why it's not importing it, because it's in the same package, maybe. I think you're right, actually. Yeah, I was going to say, okay.
But
That might be
you're
it.
right, though. I could actually use the Uno deck. I could be playing 21 with the Uno deck, and you could be playing 21 with the standard deck, and this interface would work.
Yep, interface won't care.
Mm.
Good. All right, cool. So that works. Yeah, this is our interface. So tomorrow we'll actually build the two actors. So feel free to now, with the hand class, if you want to try to update the actors you built over the weekend, over the next 2 days, go for that. Otherwise, my recommendation for homework this weekend, because I didn't get this the next 2 days, because again we are like now we're only like a half a day behind. So I got more done today than we were going to do yesterday. So that's good. I caught up a bit. Unfortunately, though, because I'm only halfway through a day, I don't have a normal assignment. So my challenges for you would be either update your actor classes to try to use this new interface. Now that you also have the hand now too. So now you have the hand now, so you can update your actor classes to use the hand class. So try to update those. And then other than that though, 30 days of code and those warm-up algorithms on HackerRank. Those are
Where
gonna be
do
your
we hand in
challenges.
the algorithm that we did today?
I will create an assignment in Classroom. So
Oh,
I'll create an
Cliff,
assignment. Yep.
can you help Keith for a second? We were looking at the hacker rank, and his screen is different. I'm not sure why.
I have to do that now.
Oh, let's
Yeah,
do it now.
just-
When are we gonna do it then?
I was just trying to be nice.
What are you gonna do it next time in class when you should already have a couple done?
Yeah.
How many did everyone get done?
How
I
many
did
algorithms
one
do we
while
get?
Cliff was gone.
I
One?
did a single one as well.
Yeah, I did a single one. And
It's because Cliff came
when
back so
Cliff came
quickly.
back,
He came
I
back in like a
finished.
minute.
Yeah, it was quick.
Appreciate that.
It would have been faster, but the assignment in HackerRank was actually incorrect. Like what they wrote as part of the challenge was not correct.
Wonderful. What?
They listed it. It was challenge number 11. They listed it as a 2D array, but it's actually like a 2D
It's a
integer
list.
list.
Yeah,
Oh, yeah, yeah.
yeah. Last year was an array, but this year is a list.
Yes, they updated it, right.
But
yeah.
they didn't update like the
No,
the
they don't always do
actual
that, yeah.
instructions.
Yeah, they did
You'd be amazed.
understand nowadays, like, I will say, warn you now that a lot of times now, whenever a Java developer says array, they 100% mean a list nowadays. Very rare that a Java developer will say a array and actually mean an array. Because you just, there's almost nothing you're benefiting out of an array versus a list. So 9 times out of 10, when a Java developer says array, they mean list.
I did the one with the binary search tree, And remember, I did it like a while back. I actually remembered how to do it from memory this time.
Damn. All
But
right,
yeah,
I'm
Keith only
reading
has this. He doesn't have access to the rest of
it. He
the,
just was on it.
yeah.
Yeah,
No, well, we gave him the link to get to there.
Oh, okay,
We-
sorry. Hold
Yeah,
on.
this is.
I forgot
I
about
don't know if
that.
you have to finish
Scroll
the
down a little bit.
tutorial.
Hold on, scroll down a bit. Right here for a second. Hold on. Hey, why is it not here?
Because it shows up for us right down there
Click
under
the preparation
tutorials.
kit. Yeah, click preparation kits.
It also
Okay.
doesn't show for me.
Nope, backup one. What the frick?
I'm just wondering if he has to finish the tutorial up in the top before accessing the rest of the
Maybe.
thing. This tutorial
guess.
preparation.
Maybe. I'm
I
surprised by
don't know
that.
though. I didn't.
It
have-
also says it's under practice for me, but I don't know where practice is for him.
I don't see it either. Yeah,
here.
weird.
Yeah, his is under prepare. Mine says it's under practice.
I'm
It's like they have two
surprised by
different
that.
sites.
I'm not sure how that happened. Unless during your sign up process, did you do something weird? I don't know.
He said he signed up under GitHub, which I did.
It's fine. Yeah, no. I
It
think
does say
sometimes-
Oh, I
prepare new
remember.
up top.
It's because GitHub has two different sign-ins. When you create your account, it's one for
Business.
like free developing, and then the other one for like when you're looking for a job.
Right.
So
That's
his
what
is
I'm wondering. I wonder if
prepare
it's-
because he's
yeah.
preparing for a job, and us it's practice because we're not actively looking for a job.
I wonder if that's what it is. Yeah. 'Cause
Oh,
when you do these
Yeah,
sign
and
up
he has
process,
the
you can-
apply at the top. I don't have the apply.
Yeah,
do
log
know,
out
yeah.
of this, Keith.
What?
What?
Just log out of HackerRank and then.
No, don't do that. Don't do that. That's not going to help. It's when you first create an account, HackerRank asks you what you're here for, and you can put in like to improve my skills, to find a new job, to improve my skills, or whatever it is. I'm wondering if you select that, it'll change your home screen a bit. I don't know. I'm surprised by that. But main thing is we gave you the links. You can do that as soon as you start one. It should then show up here. So as soon as you complete one of them, then
Yeah.
it should show up. So I would just do one of the first warm-up challenges, and then that should be up there and be saved. I'm surprised by that though. That's weird. I'm looking at that more. That's good to know. Yeah. Thanks everybody for sharing the link with them at least. Yeah, you should be able to work on this then. Keep that link. If anyone else wants to put it in the Slack so that anyone else who doesn't have it has it, that'd be appreciated. But yeah,
I
I'll
can go
put up
back to-
a assignment. What I'll do is that'll be an assignment for HackerRank interview prep. So you'll be able to upload as many of those as you can. So do as many of those as you can by tomorrow, by Thursday. So I think it's possible to get all four done, but if you get at least half, I'll be happy for now because, like I said, that's at least good. Try to do it. The goal for you guys though is to always try to do as many as you can with the time you have available. Remember ABC, always be coding. The more you do, the better you'll benefit from it. That's a key thing to remember. I'd be okay with 2 if you're mixing that in with your 30 days of code. That's why I'm saying I'm okay with 2 because if you're trying to do all 4 and 30 days of code, you're not going to get any 30 days of code done. So if you can try to do at least, if you can try to do 2 algorithms and get a couple days, 30 days of code in to get that finished, that's going to just, again, it's going to help your Java knowledge. All right. Sound good? That's the homework for tonight. That's the work I want to recommend you guys work on. Again, the closer we get to the end, the less specific assignments I'm going to give you, the more vague the assignments are going to be. So there is going to be more responsibility on you guys to find something to do during your days that you're not in class. And one of the best ways to do that, of course, is collaboration with each other. Challenges say, hey, let's meet up and work on something together. Let's build something together. You can do small teams to just build a mini project. So work together to build a small game or something, or work together to build a small little application that allows you to rent cars or something from the console. Build a more complex fruit stand together. So those are things that are going to benefit you more. The more we get closer to the end, the more it's going to benefit you guys to do some of your own personal stuff that is not asked for by me. All right. The closer
Yeah,
we
and
get,
if you're struggling, you can always like in Slack get the TAs because
Yeah.
I know they're like. I think someone was like asking for help, or someone wanted to help people, but there wasn't like not many people asking in Slack.
By all means, if you need it, at me at any time, and I will put a ping, and I will do an at channel ping immediately. So if you at me and I notice it on my phone, like I will admit I sometimes miss, but at me on it, send me a direct message saying, hey, can you alert people to my help that I need? I will gladly jump in and do an at channel ping. So, and I recommend everybody here, make sure that the channel's set to all messages. We don't really abuse our Slack system, so you're not going to get annoying constant messages over and over and over again. So I would say, I would personally recommend, I know, I'm very confident Jim has it, because every time I put the ping out to the students who aren't here, I hear Jim's computer go off. So Jim, I know, is getting pinged anytime you put any message in there. So know that Jim does that for you guys. Jim has it set that any message that goes in, regardless of the mentions, he gets pinged on it. So at me at any time, I will put the channel ping. If you guys set it up where you get pings for all messages, that'll also help you just make sure you're there to help anyone that they have problems. And even if you don't know the answer to what the person is asking about, try helping, sit in, see if you can see it. Maybe it's something maybe simpler than you think it is. Like I said, I would sit down with my classmates when I was in RNL's class, and I would help them. And I'd look at what they're doing, like, I would think in my head, like, I have no idea how you're trying to solve this problem. I have no idea your approach. It's nowhere near the approach I did. It's nowhere near what I tried to do. But instead of telling them how I did it, instead of being like, okay, I don't know how that's going to work. Here's how I did it. I would work to understand their approach, understand their problem, and try to solve it their way. And that for me would open my mind to a lot of different things. It would open my mind to different approaches, different solutions, different ways of attacking the same exact problem I just did. Now, yes, sometimes we would go through that and we would realize together, like, no, actually, you know, this is not going to solve it, actually. And that was the goal there. My goal was not to be the one to decide it's not going to work. My goal was to work with this person to figure out together, yeah, this is not working. We're not getting anywhere. Because that would help both of us realize that this approach, while interesting, is not going to work for this. And neither one of us is then going to wonder, could that have worked? Could that have worked? Could that have worked? And it helps the people to then be able to, on their own later on, realize that their problem is not going to work. If you just tell someone, do this instead, and they don't get shown how their solution isn't going to work, they're always going to wonder about that, and they're never going to feel confident that they solved it. They're going to be like, oh, this person solved it for me. So always make sure that that's how you approach anybody's asking for help. You work through their solution, not try to guide them towards yours. Make sense? And again, you do that so that you yourself also benefit from the support as well. If you just tell people what you did, you didn't learn anything new. You didn't earn anything new. You just told someone how to do what you did. So no one learned anything really. So when you work through their problem, they're getting that, they're figuring out how to work through a problem. You're learning how to approach a problem a different way and seeing different things. So the more and more we get closer to the end, the more it's going to benefit from you guys doing that, because I can only cover so much every class. I would love to be able to cover things for hours on end, but it's just gonna, we'll all get burned out, including myself. So keep working it. We're getting close. Keep it up. You guys got this. I will see you all on Thursday. Have a great night.
All right.
I'll try to get these things up in the classroom ASAP.
Peace out.
Have a good night, everybody.
Easy.
Thanks, Luke.
Good night, everyone.
Right.
Good night.
Good night.
Good night, David. That's it.